We're just going through the overseas version of the C1 paper of May 2014. We can tell it's overseas, by the way, so somewhere higher up the page it says R. Edexcel don't produce overseas papers anymore. They have what's called an international paper with a slightly different spec. So I think this was the last one with exactly the same spec, sat on exactly the same day as the home paper. So exactly the same specifications, so it shouldn't be any change. It shouldn't be feel any different to a normal paper. Okay, it says Factorize Fully, and I suppose the most obvious thing to do first is take the x out. I have seen a significant number of people leave it like that. Heavens knows how you'd think that would get 3 marks, because it's obviously not fully factorised. Here we've got a difference of 2 squares. Remember, a squared minus b squared can always be written as a plus b, a minus b. So that's equal to x, 5 plus 3x, and 5 minus 3x. There you go, that's that one done. Okay, on to the second question. 81 to the 3 over 2 is the same as, now we can either do the square root of 81 and square that, and cube it even because of the 3, or perhaps less sensibly, we could cube the 81 and then square root that, particularly without a calculator. This one I would suggest is not the way to go. So we need to be doing 9, the square root of 81 is 9, cubing 9 is going to be equal to 729. So there we go, that's our first one, part A of the question, done. Part B, we just need to deal with this and be careful we deal properly with the 4, because this is x squared, 4 squared, x to the minus half squared. Okay, note that if we got a power of something, then we've got to make sure we do the same power of both of those, hence the 4 squared there. So that makes this x squared times 16, x to the minus half squared is x to the minus 1. Okay, because we've got xmn is equal to xmn, one of the rules of indices. So that, and now we've got the x squared and the x minus 1 cancelling with each other, so that's equal to 16x. Right, now on to question 3. A pretty straightforward sequence question with this kind of rule here, this recursive rule defined for it. It says A2 in terms of k. Well, A2 is going to be equal to 4 times A1 minus 3, but of course we're told that A1 equals k, so A2 is equal to 4k minus 3. There's only 1 mark for that, because really we're just writing that down. Then it's got 3 terms. We've got 3 terms added together. Let's work out an expression for A3 now, because A3 will be equal to 4 times A2 minus 3, but A2 is equal to that. So A3 is equal to 4 times 4k minus 3 minus 3. So that's 16k minus 12 minus 3. So that's minus 12 minus 3, which is minus 15. Okay, so that's A3. So now we're told that sigma 3r equals 1 of AR is equal to 66, which basically is the same as saying A1 plus A2 plus A3 equals 66. So we've got A1, which is K, there. A2, which is 4K minus 3. And A3, which is 16K minus 15. Which is equal to 66. So that gives me 21K. And the minus 3 and the minus 15 go to make minus 18. But take that over to the other side, that makes it 84. So that gives me K equals 4. Okay, on to the fourth question. Standard differentiation and integration thing. We need to get it into the form y equals ax to the p plus bx to the q. Otherwise we can't differentiate and integrate. So we're going to spend some time working with indices. I might do it over here in a different colour. Let's do it here. Just writing it in a different way, not differentiating at this stage, just writing it as, well, it's actually not, just should have looked a bit more carefully. That's just 6x to the half, which is y equals 2x to the 5 plus 6x to the minus half. Now I can use the rule for differentiating, because our rule is dy by dx if y equals x to the n is equal to nx to the n minus 1. So let's just do it. So we've got part A, dy by dx is equal to 10x to the 4 plus 6 times minus a half from this times x. Now minus half take away 1 is minus 3 over 2. Now we're not going to, it does want it in its simplest form, so we're not going to get full credit for that. Now 6 times by minus half is minus 3. So it's 10x to the 4 minus 3x to the minus 3 over 2. Okay, that's the first part. Now second part is down a bit. Integrating. Now integral of x to the n dx is equal to, now this is the opposite of differentiating, add 1 to the power and divide by that number, add c. So to integrate, we're basically integrating 2x to the 5 plus 6x to the minus half dx. Alright, so here we've got a power, with the 2x to the 5 we've got the power of 5, so we're adding 1 to that. So that's 2 over 6 x to the 6 plus 6 x to the minus half, add 1 is a half, it's divided by a half, plus, don't forget the constant, we need that constant. Now it's not simplified, let's simplify it as much as we can. 2 over 6 is the same as 1 over 3. X to the 6 plus 12 x to the half plus c. Okay, so that's it. Now we're on to question 5. Right, question 5 is Serge's question. The most obvious thing I would think to do here, I'll move it up a bit to make myself enough room. The most obvious thing to do is to times by the square root of 2. That will eliminate the square root of 2 there. Now I could times the top by square root of 2 and just deal with the right hand side like we would normally do, but because in this one I've got it as a fraction, it might be just as well to times both sides by the square root of 2, and I think that'll come out quicker. So we've got 10 the square root of 2 plus x the square root of 8 the square root of 2 is equal to 6x. Now that gives me 10 the square root of 2. Now 8 the square root of 8 times by the square root of 2 is equal to the square root of 16, which is equal to 4. So that's 4x is equal to 6x there. I just wrote that to the right hand side because I don't think it's necessary to write it in the full work in something that can go on in your head. So then we've got 2x is equal to 10 the square root of 2. X is equal to 5 the square root of 2. Okay, so that's question 5 done. Question 6. Right, here we go. Let's write it here and leave a bit of space on the right hand side to do this. That should work well. It's an inequality question. A little bit of a context here, trying to make it a bit more interesting for us, I suppose. We can see that because this whole length is 4x and this length is 2x, kind of thing, I think you see at GCSE quite a bit there, that length must be 2x. Okay, and we can also see because this is 6x minus 3 and this is 2x plus 1 here, this length here has to be the difference between those two, which is 4x plus 2. Okay, so that's 2x. Okay, so it says so that x is greater than 1.7. So for part A, which is saying the perimeter must be greater than 40. So that's saying that let's go around. Start at the 2x plus 1 plus 2x, and this one, plus 4x plus 2, which is this one, plus 2x, which is this one, plus 6x plus 3, which is this one, plus 4x, which is this one. And we're back round. I seem to remember years ago calling it the blob method when I was teaching much lower down. Greater than 40. Teaching a few year 7s many years ago. I seem to remember doing something like that. Anyway, so gathering all our x's together, we've got 2x plus 2x plus 4x plus 2x plus 6x plus 4x. So that's 2, 4, 8, 10, 16, 20. So that's 20x, and then the numbers are 1 plus 2, that's 3, plus 3, which is 6. Okay, now that gives us 20x is greater than 34, x is greater than 1.7, 34 divided by 20, as required. There we go, that's done. Part B, given that the area of the garden is less than 120, now we can split it into two different ways. I've got this being 2x, I'm going to split it that way. This area here is 2x times 6x plus 3, and this area here is 2x times 2x plus 1. Okay, so let's so we're going to add those two areas and use the fact that that's got to be less than 120. So we have 2x times by 6x plus 3 has got to be plus 2x times 2x plus 1. It's got to be less than 120. So there we're going to have 12x squared plus 6x plus 4x squared plus 2x is less than 120. So that gives me 16x squared plus 6x plus 8x minus 120 is less than 0. Now you might think, oh, this is a bit hair-raising to factorise that, but hopefully it's an obvious factor. We can see we can divide it all by 8. So that gives me 2x squared plus x minus 15 is less than 0. Still got to work a little bit for our factorization. But we know there's going to be a 2x and an x, and then we're just playing around with the 3 and the 5 to see what happens. And you can try various things. Or I said 3 and 5. It could be 15 and 1, but you quickly see that it's not going to work. 15 there won't work because we'll have a 15x when we told those two together, and a 2x when we times those two together, so that won't work. Neither will it similarly the other way around, with a 15 there and a 1 there. And this is the kind of thing that you'd very quickly scan in your head. Is 15 and 1 going to work? And you see it's not. But 3 and 5 looks a bit more promising. If we put a 3 and a 5 there, we're going to get a 10x and a 3x, which won't get us our target x in the middle here. But if we reverse it, 5 and 3 there, looking much more promising, because I've got 6x here and 5x there, which has the difference of 1. So now it's a case of getting just the signs right. Now I've got a positive x here, so I need it to be a larger number of x's. So that's plus 6x and minus 5. Okay, so right, there's various ways of doing the next part. The next part, first of all, I'd work out the critical values. We've got 2x minus 5 equals 0, so x is equal to 5 over 2. These are critical values. I'm not dealing with the inequality yet, and x is equal to minus 3. So our inequality is going to involve those values of in some sort. I do tend to prefer the number line method for this, but there is a graphical method too, so I might do both quickly. So number line, just draw a quick number line with the numbers that we're dealing with. We've got minus 3 here and 5 over 2 here. Basically we want it to be less than 0. So let's have a look. If the number is less than minus 3, we'll find that both of the brackets are negative. You can make one up if you want. Minus 4, for example. Minus 4 would make both of these brackets negative. So the whole thing would be positive. Greater than 0, which is not what we want. If we're between minus 3 and 5 over 2, for example 0, then we'll find the first one is negative, but the second one is positive. So we've got negative times positive, which makes that negative. In other words, less than 0. And similarly, you can go greater than 5 over 2, which is any number really. We can choose 3. If we put 3 in there, it's positive. We put 3 in there, it's also positive. So it's positive times positive. And it will always follow a similar pattern one way or another to this. So that's positive greater than 0. But we need it to be less than 0. So that means that we want numbers between these two, because that's the region where it's less than 0. So that tells us that, let's put our answer over here. X has got to lie between minus 3 and 5 over 2. Okay, now there is a graphical approach as well. If you plot the graph of this, we can see it's going to have critical values of minus 3 and 5 over 2. So that means the graph goes like that. And we want the graph to be below. So we can see it's got to be between those two numbers there. It's the wrong way around there, isn't it? 5 over 2 there. And minus 3 there. Okay, so whichever method you prefer to get that. And then for part C, it says, hence find a range of possible values of x. So here we've got two inequalities that we're combining. We've got the first inequality, which was that one, all the way back up there, where we had to show that it's greater than 1.7. And we've got the second inequality here. Let's draw it on a number line. Minus 3 to 5 over 2. Let's draw that one. 1. X has also got to be greater than 1.7. Now this is 2.5, of course. 1.7 there, I suppose. So we've got X has got to be greater than 1.7. So that's saying X is greater than 1.7 and less than 5 over 2, or 2.5. We're basically looking for the overlap here, where they both occur. Look for overlap. Right, just going back to part B briefly, just thought about that whilst we were doing it. You may have come to the conclusion that X can't be negative because we're talking about a length. If you did that, it's not a problem. So you don't get any extra credit for that, but there is an argument to say that X is between 0, for part B that is, and 2.5. But it wasn't necessary to come to that conclusion. It was just accepted if you did. Because it's going back to the original problem and interpreting it. Okay, so let's go on to question 7. Okay, it's a coordinate geometry question. You almost always get one of these types somewhere in the paper. So it's all about gradients, distances, that type of thing. Right, so let's have a look at it. We've got straight lines passing through L and M. So we've got so we've got to find a gradient first. M delta y over delta x, or what a change in y, or you can say y2 minus y1, x2 minus x1. You don't have to say all of these. In fact, you could just put it straight in if you want as well. Change in y, so let's say change in y, it's going from minus 4 to 2. Over change in x, which is going from 7 to minus 1. So that gives me minus 6 over 8, which is minus 3/4. Okay, now we need to find the equation for it. We can then just quote the formula y minus y1 equals mx minus x1, which is my preferred method here. I know some of you are still using y equals mx plus c and working out c, which is fine. So we've got y minus, let's put this one in, y minus 2 is equal to minus 3/4 x minus 1, which is obviously x plus 1. So that's 4, let's multiply through by 4. 4y minus 8 is equal to minus 3 times x plus 1. So 4y minus 8 is equal to minus 3x minus 3. So we have 4y plus 3x minus 5 equals 0. Part B, it's all about the gradient. If the gradient of this is minus 3 over 4, then the gradient of this one must be 4 over 3. So the gradient of mn is basically minus 1 over minus 3 over 4, which is obviously 4 over 3 as I've just written. So we can use that to work out P here. So we have the change in y, so that's p minus 4, so that's p plus 4, change in y, over the change in x, which is 16 minus 7, is equal to 4 over 3. Let's write that more carefully. 16 minus 7 is equal to 4 over 3. 16 minus 7 is 9. So we have 3 times p plus 4 is equal to 9 times 4, which is 36. So that's 3p plus 12 is equal to 36. 3p is equal to 24, so p equals to 8. Right, and the final part is just to, says that there's a rectangle. If this point here makes a rectangle, and we've got the k here, we've got the k here, what's the y coordinate? Well, notice that the y coordinate from minus 4 goes up 6 from M to L, so it will similarly go up 6 from P to K. Well, P, so the y coordinate of K is going to be equal to P, which is of course 8, plus, as I say, because it's gone up 6 here, it'll have to go up 6 here as well, so that's p plus 6, so that gives me 8 plus 6, which is 14. Okay, on to the next question. It's an integration question where we work out the constant, because we're given some conditions here, so it's quite standard. Right, I suppose again the first thing we need to do is get it in the form ax to the p plus bx to the q first of all. So that basically, well, it's the x square root of x, which is the main issue, which is x to the 1 times x to the half, which is x to the 3 over 2. So this bit is x to the 3 over 2. So let's just write that up. dy by dx is equal to 6x to the minus half plus x to the 3 over 2. Let's integrate it. So y equals x to the plus half, 6 divided by half, that's of course 12, but I'll write it in like that for the moment. X to the 3 over 2, so that's 5 over 2, 1 to the 5 over 2. Don't forget the c. A lot of people have been forgetting the constant, and we're going to work out the constant in the next part. So that equals to 12x to the half plus 2/5 x to the 5 over 2 plus c. Okay, so now we can use this. So when x equals 4, y equals to 37. So we've got 37 is equal to 12, 4 to the half plus 2/5, 4 to the 5 over 2 plus c. So that gives me 37, 4 to the half is equal to 2, so that's 12 times 2, plus 2/5, 4 to the 2/5 is 2 to the power of 5, because the square root of 4 is 2. 2 to the power of 5 is equal to 32. Right, so that gives me 37 is equal to 24 plus 64 over 5 plus c. So c is equal to 13 minus 64 over 5, taking all over to the other side, which is 65 over 5 minus 64 over 5, which is equal to 1/5. Do write it back in. You might get away with it, but I wouldn't be taking a chance. Write it back in with the function with the value of c Now we've now inputted in. Okay, so that's question 8 done. Now on to question 9. Okay, so first of all, this is linear with gradient free and intercept k, so let's just draw that. And this one's quadratic, which is because there's no term in x, it's going to be symmetrical about the y-axis and going through 8 there. Okay, so there's various things we could do with part B. We could solve a simultaneous equation, use the fact that if it's a tangent, it's got equal roots, which is a little bit an unusual way of doing it. I suppose the most obvious thing to do is to use differentiation, so that's what we're going to do. We've got y equals to a third x squared plus 8, so dy by dx is equal to 2/3 of x. But we want dy by if it's a tangent, that must mean the gradient has got to be 3. So that tells us dy by dx equals 3. So that gives us 3 is equal to 2/3 of x. So x is equal to 9/2 or 4.5. Okay, so that gives us x is equal to 9/2. We can then work out the y coordinate because we're going to need both of them, and then therefore work out k. So we'll have y equals to 1/3 of 9/2 squared plus 8. So that equals to 81/4, a third times 81/4 plus 8. So that's 9/4 plus 8. So that's 32 plus 4, that's 41/4. Just spotted a mistake there, of course. 81 divided by 4 is, of course, not 9. So let's do that again. 27/4 plus 8. That's 32, that's 59/4. Okay, so I could now, if I wanted, go back to use y minus y1 and work out the equation from the coordinate. Or I could use the fact that the two equations have got to be the same at this point, but I've worked out y is equal to 59/4, so I'm going to do that. I'm going to basically put it into this form here. So we've got y minus y1 is equal to 3x, and y1 in this case is obviously 59/4. 3x minus the x coordinate, which is 9/2. Of course, we want it when x is equal to 0. So what? So we can say y equals k if you like. So we have k minus 59/4 is equal to 3 times minus 9/2. So k is equal to minus 27/2 plus 59/4. So that gives me minus, because we are working without a calculator here, so 54/4 plus 59/4, which is 5/4, which is our answer, 1.25 if we prefer. Okay, there were various ways about going about that. Thinking about it, it might have been quicker to not work out the 59/4 at all, and just to put it into this equation, put the value 9/2 back into this equation, which has to hold, which is 3x plus k is equal to a third x squared plus 8. Okay, I could have put 9 over 2 in there instead. And I could have also got the answer that way, probably slightly quicker, but it's not really matter. Okay, so a third times 9 over 2 squared plus 8, and that would get me eventually to k is equal to 1.25. Try it yourself if you like. Okay, so that's not the way I've done it on this occasion. Sometimes you reflect back and I could have done it a bit quicker, but it's okay. It's not like that was a bad way of doing it. Okay, question 10 is a series question by the looks of things, a word question where there's quite a bit of information to take in. Okay, so we've got a bit of information here. So we've got that Zin runs A on the first day, and the common difference is D plus 1. So we've got A is equal to big A, and we've got the common difference, it's a bit of a strange one, but is equal to D plus 1. That means the common difference is equal to D plus 1 in this particular situation. Okay, so we've got on 14, let's call it U14, is equal to A plus n minus 1d, so that's 13 times d plus 1. So that's, we probably better quote the formula, because it's almost like we're writing the answer down now, right, isn't it? Plus n minus 1d. We probably need to be a little bit careful here, because it is saying so that, and it's kind of obvious, so we really do need to take care that we actually do so that. So we're putting into that formula, so U14 is equal to A plus n minus 1, so that's 14 minus 1, times by D, which is D plus 1, and now I think it's okay to write the answer. Always have to be a little bit careful when we're being asked to show something, that we're not just writing the answer down because we can see that it's true. Okay, so there we go. That's the first part is that's first part done. Second part, B. Yi has been given a 14-day schedule by a coach. You will run A minus 13 in this case for Yi, and has a common difference of 2d minus 1. So U14 in this case, now in this case, because they're not asked to show it, we can just write it out because it's pretty obvious really. So I've got this first term was A minus 13 plus 13, which is 14 take away 1 times 2d minus 1. So that equals to A plus 26d, when I multiply that, because 13 times 2, minus 13 minus 13, so that's minus 26. And it says, given that they run the same length of time on U14, so if they're the same, then we've got to have these two the same. So that gives us A plus 13d plus 13 has got to be equal to 26d minus 26. Okay, so that gives me 13d. The A cancels. I've forgotten there was an A on this side as here. Doing the other way around. There. So the A cancels, and we get 13d is equal to 39. So d equals to 3. Okay, and then finally part C is now, that's about the series, and we're back to this expression here. They're doing that so that so that you can kind of retrieve yourself if you haven't managed to do part B, because we have an expression for, or at least we know a little bit about Zin here, and that they run 784 over 14 days. We've got again, we're back to our original situation. So A is equal to A and D is equal to D plus 1. But in this case, we know that D is 4 in this case, because we've already worked out to be D is 3. So we want to work out A. So we have, let's quote the formula. Sn is equal, it's always a good idea to quote the formula that you're using. Don't normally get marks in that, but you'll normally be more generous with method marks from this point onwards if it all goes slightly wrong. So we've got n is 14, so we have 784 is equal to 14 over 2, 2 big A plus 13 times by 4. Okay, so that's 784 is equal to 7 times 2A plus 13 times 4, which is 52. Right, now you might be tempted to times through by the 7. I don't think it would be the best plan here. Remember, this is a non-calculator test, so we don't want to be making our numbers bigger if we can. I might be just tempted to see if 784 divides by 7, and of course it does. That's 1, 0, and 7, 112. 7's into, so that gives me 112 is equal to 2A plus 52. So I have 2A is equal to 60. A is equal to 30. Okay, so last question. Okay, so looks like tangents and normals question here. Right, let's get on with it. We've got an expression here, so that the equation of the normal at A, and this has got an x coordinate of 2, so we need to work out the y coordinate there. We need to differentiate this and use the fact that it's a normal to get that question. So let's just do that then. Let's work out y when x equals 2. First of all, when x equals 2, y is equal to 20 minus 4 times 2 minus 18 over 2. So that's 20 minus 8 minus 9. So that's equal to 3. So that coordinate there is 3. Okay. And then, so that's 3. Now let's differentiate that. We've got y equals 20 minus 4x minus 18x to the minus 1. dy by dx, the 20 disappears. Minus 4x differentiates to minus 4. Minus 18x to the minus 1 times by the minus 1, so we get plus 1, so it's plus 18x to the minus 2. So when x equals 2, dy by dx is equal to minus 4 plus 18 over 2 squared. So it's minus 4 plus 18 over 4, minus 4 plus 9 over 2. Working that, which is 4.5. So it's minus 4 plus 4.5, so that's a half is the gradient of the tangent there. So that must mean the gradient of this normal is minus 2. So gradient of the normal is minus 2. So now I'm going to use y minus y1 is equal to mx minus x1. So that's y minus the y coordinate which we just worked out, which is 3, we worked that out up here, is equal to minus 2x minus 2, and hopefully that gets us to the required answer, which of course it does. So that's y equals minus 2x plus 7 as required. Okay, so that's that part of the question. We're nearly at the end of the paper now. It says the normal to C at A meets C again at point B. use algebra to find the coordinates of B. So we've got minus 2x, we're basically finding where these two meet. 20 minus 4x minus 18 over x. Okay, so it's going to be a quadratic. This is going to break down to a quadratic, but let's tidy up first. Let's bring the x's over. 18x is equal to, I'm bringing that 18x over here, is equal to 13 minus 2x. So 18 is equal to 13x minus 2x squared. So I'm bringing it back over again. 2x squared minus 13x plus 18 equals to 0. Okay, now it may think, oh, that's not the easiest things to factorize, but I know that one of the coordinates it meets is 2. So I know that one of the factors is x minus 2. So the other one must be 2x minus 6. 2x minus 9, which is equal to 0. Remember, this is basically corresponds to point A. So we don't need to justify that. We can just leave, I'm just writing it here. Because that's one of the points where we started off with it meant. So we've got x is equal to 9 over 2. This is where we need to read the question carefully. It says the coordinate. So we've got x is equal to 9 over 2. We've got to put it back into the equation, but let's put it back into that one, shall we? Because we know it's true, because it's given us, and it's linear. So that gives us y equals to minus 2 times 9 over 2 plus 7. So that's minus 9 plus 7, because the 2 cancels. So that's minus 2. So that's 9 over 2 and minus 2. And that's the whole paper done in 47 minutes, slightly longer perhaps than some of the earlier papers we've done recently, but still not too bad, a few tricky bits towards the end. Okay, that's it.